Okay, folks, we're gonna go ahead and get started. From now on, just plan to keep your name tags. Try to remember to bring them back. That way, I can use them like that was originally intended, which is to know who's who. But now that I'm passing around a sign-in sheet every single class and using it to determine who was and who was not here, the name tents are more useful from this perspective, me looking out, than taking roll. So again, go ahead and keep your name tents from now on. So what I want to do is I want to focus today on the cations. We introduced that topic on I introduced the topic of ions on Monday. Basically, ionic compounds contain an ionic bond. Ionic bonds are the electrostatic attraction between a cation and an anion. A cation is a positively charged ion that results from the loss of electrons from the atom to make the ion. The anion results from the gain of electrons to go from the element to the ion. As we went through this on Monday, I mentioned the fact that with respect to the cations, group 1 always forms a +1 cation. Group 2 always forms a +2 cation. And then I gave you a stair step starting with silver. And that stair step are the other elements whose charge is always the same. So silver, when it is part of a ionic compound, will always form a +1. Zinc and cadmium, when they are part of an ionic compound, will always form a +2. And aluminum, gallium, and indium, when they are part of an ionic compound, will always form a +3. Folks, you need to know this grouping of elements when it comes to naming compounds. If you do not know these cations that always form the same charge, in an ionic compound, then you are not going to be able to properly name ionic compounds. Because to name a cation of an element that always has the same charge, you name the metal, followed by the word ion. So, Na. Na is sodium. It is in group 1. Group 1 always forms the same charge. It always forms a +1 charge. So Na plus is called sodium ion. Strontium is in group 2. Group 2 always forms a +2 cation. Because it always forms the same charge, then Sr2 plus is strontium ion. Cadmium always forms a +2. So Cd2 plus is called cadmium ion. So again, for metals that always form the same charge, as long as they always form the same charge, then you simply name the element followed by the word ion. Now, if you'll recall, all metals not listed above can form cations with more than one charge. So that's why you got to know the metals that I listed previously. Group 1, Group 2, silver, cadmium, zinc, aluminum, gallium, and indium. Because if it's a metal and it's not Group 1, Group 2, silver, cadmium, zinc, aluminum, gallium, or indium, then it can have more than one charge. For example, an example I gave you was iron. Iron can make iron 2 plus, or it can make iron 3 plus. It is initially tempting to call both of these iron ion, but that is incorrect. That is because no two ions can have the same name. So it's insufficient to simply call it by the metal and by the charge. I mean, by the metal, followed by ion. So with metals that have more than one possible charge, Roman numerals are used to indicate the charge. So in other words, if we have a +1 charge, then we'll use the Roman numeral 1 in parentheses. If we have a +2 charge, then we'll use the Roman numeral for 2 in parentheses. +3, Roman numeral for 3, and so on, where 4 is IV, 5 is V, 6 is VI, and 7 is VII. We don't go past 7. Yes. Yes.
I don't know if you're gonna talk about this later, but how do you know, like, how much charge, how many ions and
That's actually quite a good question. So in this particular course, we're not going to go into the details that allow us to know what the possible ions are. However, when we get into naming, I will teach you how to figure out what the charge is. To actually answer your question about how do you know what the possible charges are, we would need to look at the electron configurations for the atoms of the elements. So in College Chemistry 1, if you take that, you'll definitely learn it. General chemistry for health sciences, I'm not entirely certain if they do electron configurations anymore or not. So that's one reason I'm not teaching it in this class, is because I have a mixture of individuals that'll be taking general chemistry for health sciences and College Chemistry 1. So I'm trying to make sure I cover things that are in both classes. Okay, so let me go back to my iron example earlier. I said that iron can form 2 different charges. It can form an iron 2+, or it can form an iron 3+. We could not just simply say iron ion, because no 2 ions can have the exact same name. So to distinguish these, the iron 2+ will be iron with the Roman numeral 2 ion, whereas iron 3+ will be iron with the Roman numeral 3 ion. Basically, the Roman numeral again is stating the charge on the metal. And we call it, so when we verbally say it, we say iron 2 ion, iron 3 ion. So at this point, I think practice is good. Number 1, you need to get familiar with the elements that only have 1 charge. And number 2, number 2, you need to get be prepared to actually name the ions, especially when we start naming ionic compounds. So, I do want to mention one little detail before I move on. I will do my best when picking out homework questions on active to make sure that it follows IUPAC naming. And this is called, what I've been showing you is called IUPAC naming. IUPAC is basically the governing body that tells us how to name a compound so that no matter whether we're here or whether we're in China or whether we're in Russia or India, we all name it the same thing. But there are, I told you when we were going over the periodic table, there's some elements known to the ancients, and iron just happens to be one of them. So I will be passing out a sheet on Monday that demonstrates this, but iron 2 you may also see as ferrous iron, as just ferrous iron. And iron 3 you may see as ferric iron. That is using the old naming system, the Latin naming system for iron. And so I will do my best for the upcoming homework to make sure that there is no Latin naming system. But on Monday, when I pass out the sheet, you will see iron 2 listed 2 ways. It'll be listed as iron 2 and also as ferrous. I'm only asking you to memorize how to do it using the IUPAC naming system, because to me, that's the most straightforward. Okay, so practice. Actually, let me change it up just a little. Okay. So aluminum is element number 13. It is part of that stair step. It is in the 3-element step. So it has a +3 and it's called aluminum ion. Okay, potassium is a group 1 metal. Group 1s are always a +1. So it's potassium ion. Barium is a group 2 metal. It's always a +2, so it's barium ion. Rubidium is a group 1 metal, so it's always a +1, so it would be called rubidium ion. Zinc is in that stair step. It is in the 2-element step, so that means it's a +2, and so it's called zinc ion. Indium is in the stair step. It is in the 3-element step. So it's a 3+ charge and it would be called indium ion. Questions? Yes. It does not matter for this course. When you get to, if you take college chemistry 1, and again, I cannot remember if they do this in general, what I'm about to describe in general chemistry for the health sciences. The reason we typically write the number before the charge is so that we can distinguish a charge from an oxidation state, which they will talk about in college chemistry 1, I know. I cannot remember. It's been so long since I've taught general chemistry for health sciences. I don't know what is taught in that course anymore. Yes.
Is there any reason Roman numerals?
Because these metals always have the same charge. You only use the Roman numerals on the metals that have more than one charge possibility. Other questions? Group 1 metals all have a +1. Group 2 all have a +2. Yes.
So how did you do, how do you do these? Is it the same?
It's this nice little stair step. If you start at silver, they literally look like stairs, is why I call it a stair step. Silver is the only element in that particular step column, so it's a +1. In the zinc cadmium column step, there's 2 elements, so that they're both +2. In the aluminum, gallium, and indium column for the step, There's three elements, so they're all plus three. So the stair step is the best way that I have to explain that and to also help you remember exactly what charge they have. Okay, now I'm gonna mix them all up. And I'm gonna give you the iron and I'm going to have you name the iron. Hmm. Yes, sorry, I'll rewrite it to make it make sense.
So with the Roman numerals, is the rule, if it's not in the stair step, you use the Roman numerals, or if it's not in group 1 or 2?
Correct.
Okay.
If it's a medal and it's not in group 1, it's not in group 2, and it's not in the stair step, then you use the Roman numeral. It is in this, oh, I goofed. I got to going too much. My brain is dead. Okay, so scandium 3+ will be scandium 3 ion. Cesium plus will be cesium ion because it's group 1. Beryllium 2+ because it's group 2 will be beryllium ion. Cobalt 4+ will be cobalt 4 ion. Gallium 3+ because it is in the stair step is just gallium ion. Gold plus is gold 1 ion. Ag plus because it's in the stair step is just silver ion. V5+ is vanadium 5 ion, and calcium 2+ because calcium is in group 2 is just calcium ion. Questions? Thank you for catching my error. Okay. So what we have done is we have talked about the metal cations. In the last couple of minutes, I want to talk about polyatomic cations. There are 3 cations that are not metals. Actually, only 2 I'm going to require of you. So let me change that to a 2. 2 cations that are not metals. They're called polyatomic cations. If you break this word apart, poly means many. Atomic means atom. So in other words, we're looking at many atom cations. If you are familiar with polyatomic ions, the majority of them are anions, which we'll discuss later on. But there are only 2 cations that you need to know. Now, with respect to the polyatomic cations, two things to note. The formula, or in other words, the number of each atom, never changes. And the charge never changes. So in other words, you can basically memorize these because they're always going to be the same. The two cations include 1 nitrogen and 4 hydrogens and carries a +1 charge. This polyatomic ion is always called ammonium. Do not confuse ammonium with ammonia. Somebody has heard me say that. Do not confuse ammonium with ammonia. They are two different things. The other polyatomic ion has 3 hydrogens and 1 oxygen. And carries with it a +1 charge. And this is called hydronium. And I do not care which class you are in. I know this one is in general chemistry for health sciences. It is also in college chemistry. You will see hydronium a lot. You will see ammonium in both. But folks, if I were to give you NH4+, I would expect you to spout out ammonium. If I would give you H3O+, I would expect you to spout out hydronium. If I gave you the word hydronium, I'd expect you to write it as H3O+. If I were to give you the word ammonium, I would expect you to write it as NH4 with a +1 charge. They are always the same, whether in name or in formula. They are always the same. Questions? Okay, so today my entire focus was cations. On Monday, we will start getting into anions and polyatomic anions. And we will spend a day to 2 days on polyatomic anions because there are a lot of them. And you do have to memorize them. And I'm going to hopefully teach you how to memorize them. And then we're going to play bingo with our polyatomic ions. And bingo winners will have candy bars. So. Okay, I will not see you on Friday. Dr. DeRocher will see you on Friday. No. Yes, Dr. DeRocher will see you on Friday for the test. I will see you on Monday.